This video is going to go through two examples of how you can find an equation for a quadratic function if you're given some information about the graph or the equation. So all we've done so far is that I've given you some equations, functions, and you've graphed them, but here you're going to be given some information. So let's look at our first example, which says find the quadratic function which has its x-intercepts at 2, 0 and negative 3, 0 and a y-intercept at 12. So because we're given both x-intercepts and a third point, we're going to want to use the formula we learned today, which is the x-intercept form for a quadratic. And again, that form is here, y equals a times the quantity x minus x1 times the quantity x minus x2. And if you remember, x1 and x2, these values here, are our x-intercepts. So since we have our x-intercepts are at 2 and negative 3, I'm going to put those values in for x1 and x2. It doesn't matter which one you put in for x1 and which one you put in for x2. So the first step was choosing the appropriate formula, because we now have 3 different function formulas for quadratics that we can use. So we've chosen our x-intercept form. And the second step is to actually substitute those x-intercepts into the formula. So you'll see now that I have x minus 2, because my first x-intercept was at 2, and x plus 3, because my second intercept was at negative 3. And if I have x minus negative 3, that would give me x plus 3. So the only thing left to solve for is a. And so to do that, we're going to use this other piece of information that we've been given, which is that we actually have another point on our quadratic, on our parabola. We have the point 0, 12. So we're going to substitute that in, and that's our third step, to solve for a. So if I substitute that point in, then the only thing I'll have left for a variable is a, and so I can solve for that. So you'll notice I'm putting in 12 for the y-coordinate and 0 for my x-coordinates, because again, the point was 0, 12. So my x value is 0 and my y value is 12. So you put those in, do out the math that goes along with that, and no need to distribute and all of that. I'm just going to do 0 minus 2, which is negative 2, 0 plus 3, which is 3. I'm multiplying those two things together, so I get negative 6a is 12, and so a is negative 2. And then I just substitute that into my formula, and I have my equation for the quadratic. So that's our first example. Make sure you have all of this in your notes as usual. These two examples you'll just put in section 5.6. It's a continuation. Let's do one more example. Okay, our second example. Find the quadratic function which has its vertex at negative 1, negative 8, and passes through negative 4, 10. Passes through negative 4, 10 means that that's another point on our quadratic. Now, in this example, it's different than the last one, because in the last example we were given the x-intercepts, and in this example we're given the vertex. So, because I'm given the vertex, it would make sense for me to use vertex form. So that's our first step. We're going to choose the form. And if you remember, our form is y equals a times the quantity x minus h squared plus k, where h and k are standing for our vertex. So our second step is going to be that we're going to substitute this in for h and this in for k. And so I've done that here. So I'm saying substitute in the vertex, and you can see again that because it's usually x minus h in our equation, my h value is negative 1. So x minus negative 1 becomes x plus 1. And then my k value is negative 8, and so it's negative 8. So just like we did in the last example, now I need to solve for a. So we have our vertex filled in, and I'm going to now use the second point that I was given, which is negative 4, negative 10, and this is my x value, negative 4, so I'm going to replace x with negative 4, and I'm going to replace y with 10. And so that's our third step, is to replace, sub in the additional point, and solve for a. So again, you can write that into your notes. You'll notice, let me get the laser here, that my y value is 10, my x value is negative 4, and now I'm solving this. Careful with your order of operations. I'm going to do what's in parentheses first. Negative 4 plus 1 is negative 3, which when I square it, I get 9. And be really careful with this. It's tempting to want to do 9 minus 8, but keep in mind that it's a times 9, which is 9a. So it's actually 9a minus 8 is 10. And if 9a minus 8 is 10, then 9a is 18, and a is 2. And then I go and I substitute that in with my vertex. X and y will stay x and y. So be really careful with that last step. Maybe take a second to think about that. Hope this video was helpful, and I will see you in class.